This is Rushali and you are watching Rushraj Classes YouTube channel. As you know, we have started the important theorems of chapter Circle of Standard 9th. Two theorems are already done. You can check the link in the description box. Now from next theorem onwards, that is from theorem number 3. Theorems are important. Yes. Now from third theorem onwards, these theorems are important. So now let's proceed further with the theorem number 3 of chapter Circle of Standard 9th. Now what is this theorem number 3? What theorem 3 says? Theorem 3 says that the perpendicular from the center of a circle to a chord bisects the chord. What is the meaning of this? If we draw a perpendicular from the center of this circle to the chord, that perpendicular line bisects the chord. Theorem is quite simple but important. So let's start with this theorem. So by this time, all of you know that the first thing required to prove any theorem is the correct figure required for the proof of that theorem. So here is the required figure for this theorem. Here AB is the given chord. OM is perpendicular. Let us mark this. OM is perpendicular to chord AB. And what we have to prove? We have to prove that this OM bisects the chord AB. For this, we will have to do one simple construction first. Okay, simple construction. So what I did here, join OA and OB. This is required for this proof. Now let us start writing our proof. Given we have a circle with center O, then AB is chord, OM is perpendicular to AB. From this, we have to prove that OM bisects chord AB. For this proof, what did we do? One simple construction. Let us write that. If we do any construction for the proof, we have to write that as a step of the proof after this. So let us write that. Construction. What did we do? Join OA and OB. Now when we join this OA and OB, we get two triangles here. That is triangle OAM and triangle OBM. We are going to use these two triangles for the proof. Proof is quite simple. Proof: in triangle OAM and triangle OBM. First thing we know that OM is perpendicular, means angle OMA and angle OMB. These two are right angle, means measure is 90 degrees. Angle OMA equal to angle OMB, and this is 90 degrees. Now why this is 90 degrees? Because OM is perpendicular to AB. We have to write reason for each and every step what we write here. Let us write here. OM is perpendicular to AB. Next, OA equal to OB. OA equal to OB. Simple reason, these two are radii of the same circle. So these are equal. Radii of same circle. Okay. Next step. Here for these two triangles, that is triangle OAM and triangle OBM, OM is common side. Means OM is shared by triangle OAM as well as triangle OBM. So OM is common. Now what all things we have here in these two triangles? We have one right angle, OA and OB, which are two equal sides. These are nothing but the hypotenuse of these two right angles. See, OA, it is side opposite to 90 degrees. OB is also side opposite to 90 degrees. So this hypotenuse of both the triangles are equal, and we also have one equal side. So these two triangles are congruent by RHS postulate. Triangle OAM congruent to triangle OBM, reason RHS postulate. As these two triangles are congruent, AM equal to BM, AM equal to BM. These are corresponding parts of congruent triangles. AM equal to BM. What is the meaning of this? M is midpoint of AB. This means OM bisects chord AB. That is OM bisects our chord AB. So this proof is so simple, so easy, but it is important for the exam. So whenever we draw a perpendicular to a chord from this center, it always bisects the chord. So this was our third theorem of chapter circle. Fourth theorem will be done in our next video. So for that, please be in touch, subscribe our channel so that you will get the regular updates of this upcoming videos. Thank you so much for watching this video.